detection. So I'm happy to welcome you all to today's webinar with UbiAi AI. And also we've got Walid, who is our founder and CEO. And he has a very storied and distinguished career, an ex-Intel research engineer, PhD in physics. I have to call him Dr. Walid. And so he has been serving Fortune 500 companies across finance, healthcare, and supply chain with UbiAi. And as we were just mentioning, is from Raleigh, North Carolina. So he is going to collaborate on this webinar today with Dirk Nickel, who I had the pleasure of meeting this week. And Dirk is a senior technical product executive, and he focuses on product management and product marketing, growth marketing, go-to-market strategy, and execution. And you have 25 patents?
Yeah.
Is that correct? Oh, wow. I'm very glad to know you. And you're ex-IBM, and you also live in North Carolina in Durham. And I am Sarah Lloyd Favreau, and I like to term myself a global responsible AI leader. I focus on responsible AI and AI governance, as well as AI transformation, especially around elements in corporations or big organizations like workforce readiness for AI. So I have a company called Learn Bold Global Responsible AI, and I work with different partners and clients to really help them introduce AI into their operations or to take AI to the next level if they've already had some dabbling with some of third-party tools and they want to up the ante. So I live in Washington, D.C., technically in Virginia, Arlington. And I'm sure all three of us, we would love to connect with you via LinkedIn and talk with you if you have any one-on-one conversations you'd like to pursue afterwards. So I will hand it off to Walid and Dirk. Thank you so much.
Yeah, you see this? Do you see the screen, Sarah?
I do.
Okay, great. Yeah, thank you so much for the introduction. So today we're going to focus primarily on the use case of fraud detection and how AI agent can help with that. So the first section, we're going to basically talk about the current approach to fraud detection and what are the limitations. And Dirk is going to actually address these slides. Next, we're going to talk about like how generative AI plus traditional machine learning can actually increase the efficiency and make this black box problem less of a problem of these traditional machine learning models. We're going to introduce what UbiAi is. And next, we're going to talk about our use case for today, which is we're going to focus primarily on credit card fraud transactions. And we're going to see how basically AI agent will help with that, in addition to traditional machine learning models. And finally, we're going to do the demo, which is why probably most people are here. So we're going to do a demo and then a question answering after that. So I will let Dirk take it from here to basically introduce the topic.
Yeah, thank you. This is a really critical topic. The idea is fraud and AI. As we all know, fraud and fraud prevention is a really critical issue these days. This chart here shows just the massive amount of increase in fraud over the years, and it's just not stopping. So 43 billion in fraud just anticipated for 2026. Every 14 seconds, somebody at least in the US, is a victim of identity theft. 150 million Americans will have some form of credit card fraud. So it's on the rise, definitely. And it's not just because of the opportunity which is there for the fraudsters to take this technology to the next level, but also AI is playing a big role in identity theft and fraud and these whole areas of fraudsters versus the good guys. And so if you sort of think about this space, it's really an arms race between the good guys and the bad guys. So the fraudsters are constantly upping the ante with new technology like card testing validation with AI, or evading detection, or deepfakes to evade detection, scaling operations with agents, and transaction frauds. And so this is also an area where the good guys, the corporations and merchants, need to prevent attacks. So it's a constant arms race between the two parties in this growing space of fraud. So if you go to the next slide, we're going to talk today about fraud prevention around transactions and credit cards, but it's broader than that. It's everywhere. It's identity theft, insurance fraud, corporate fraud, system hacking. Fraud attacks are on the rise, and AI is a real big enabler of that. And so as we go to the next slide, there's been a fair amount of work, as you know, in preventing fraud over the years, but there's room for improvement. Today, the way it usually works is they use a rules-based approach where basically you go through and map out how do customers interact with your systems, and if there's an anomaly, it's sort of an if-then. If this happens, then we detect a fraud. And as time has gone on, we've improved that with AI. Machine learning is one example of that, where you're using predictive models, where you're looking at historical transactions and different patterns, and using some sort of neural network techniques to do some prediction. So even though there may not be data there to show that there's a fraud, but it's predictive behavior. So that's been a big breakthrough, but it's not the full story. As the fraudsters become more sophisticated, the good guys have to be more sophisticated too. And that's where AI comes in. And there's limitations with the current approach around zero day. So like if you're thinking about the pattern recognition, what if there's a novel attack that has never happened before? Or maybe the patterns have been there for a while and are biased. Or if there is a detection of a fault or a potential fraud, was that biased somehow? And so there's lots of different holes, I'd say, in the current approach to detecting fraud and fraud patterns. This is where AI can play a bigger role. Now, we talked a little bit already about machine learning. That is, of course, AI, but it lacks some of the more sophisticated adaptability and reasoning aspects that some of the newer technologies offer. Things like agentic AI or agents or generative AI. So from an AI perspective, some of these new technologies like autonomous agents can do real-time monitoring. They can look at continuous scanning patterns. They can mimic some of the patterns or the behaviors of a human, overlooking and detecting fraud and behavioral problems. It can do autonomous investigation, where it can go out and flag transactions. It can do self-learning through reinforcement learning. From a generative AI perspective, you can also do things like synthetic pattern recognition, where you're generating new data to augment existing data that you may have. It can do deepfake detection, where the fraudsters may have a deepfake, but you can do deepfake detection on the AI side. Document validation, looking at the ways that patterns of passports or invoices or contracts, or use adaptive fraud prevention using AI to do reinforced learning and preemptively recognizing evolving threats. And so these patterns become much more possible with AI. In addition, things like email patterns or voice recognition, multi-factor authentication with reinforced learning. All these sort of things are new tools that the merchants have and to combat AI from the fraudster standpoint. The big thing to take away from this is that it's evolving, right? You need to be adaptive. Things like AI can bring accelerated processing, large volumes of transactions data, faster fraud detection, learning and adapting to new patterns, automated prevention, looking at fake pattern recognition, difference between real users and automated fraud users. All these things are possible now with AI. Things like proactive learning and monitoring, looking at threats in real time, or fraud detection and accuracy. So just to sort of wrap this up, the thing is that there is a big arms race going on. There's always new technology on both sides. And the trick is being adaptive, being able to use these technologies to adapt to new threats. And it's not just autonomous, but humans are always going to be involved in this process. So how can we augment the human checking of threats and faults by helping them scale, helping them be more proactive, helping them have more insight into the behavior of the fraud patterns. So this notion of reinforcement and adaptability is critical as we kind of move forward in this space. And AI, things like AI agents and generative AI are critical tools for that adaptability and reinforcement of technology and reinforcement of learning. So with that, I'm going to hand it over to Ali to kind of take to the next set of topics.
Yeah, thanks, Dirk. So that was a great introduction on the fraud sector. So as you mentioned, so basically AI is not a silver bullet, meaning you don't, it's not like a solution that you set it up once and it just works. And the reason is because the world is dynamic and constantly changing. And there is this concept of data drift where the data suddenly changes in the distribution. So for example, you might start with a certain distribution, and then after a certain amount of time, the data completely change. So this could be due to, the fraudster in this case, changing their strategy, or the world has changed, or there's some dynamics that's, working in the background. So in that case, the AI is actually not, is not, basically it will inevitably, the accuracy of AI will inevitably decrease because of that. So one, I think, the big misconception is like AI is going to solve everything, but it needs to be basically constantly updated to the actual world, how the world is changing. So this is a big problem in AI, and honestly, it's also probably why a lot of AI projects are failing, because they are lacking all this reinforcement learning and constant updates of the AI systems. So how do we make sure our AI stays relevant and stays accurate over a long period of time? So what is typically done is reinforcement learning is one of the solutions to basically keep the AI up to date. So how does this work is you start with an AI model. So let's say you are basically have an LLM, like large language model, like DeepSeek model or OpenAI or whatever, like Mistral model. So you start with your base model, and then you start collecting the data and start querying or using your model in production. And then as you use the model, you start collecting feedback. You start actually collecting the output of the model, and then you have a human that will basically rate the truthfulness or this whatever the metric that you care about, like factuality, truthfulness, correctness. So the human is going to rate that response, and then after that, after a certain period of time, you can basically collect that reward, what you call like reward data, so preference data, and then with that you can actually train another model. We call this a reward model, that will basically learn what's good, what's bad, what's good, what's like correct or incorrect, truthful or not truthful, based on an input and an output of the model. And then what happens is this reward model act as a teacher, and it will teach the base model based on the truthfulness or the correctness that you care about. So basically, by iterating between the teacher and the student, the reward model and the base model, you can actually guide and align this model better to new data that comes in. And then what you do is after that is you kind of redeploy this new version of the model in production, and then you redo the same thing over and over again. So this is the loop that's we call like as a reinforcement learning, and you have to do this. It depends on the variability of the environment, but you might have to do this like once a month or once every 3 months. So this is basically a way to keep the model up to date and always aligned to your objectives and goals. And this is pretty much what we do at UbiAi. So we focus primarily on the most pressing issues right now in AI, which is basically how do you create like reliable and accurate AI over time? So UbiAi allows you to collect the training data needed for that with different techniques, and then after that you can basically train your own AI on that specific data that you have collected. And then using reinforcement learning, you can basically improve that model over time and make it better and monitor it over time. So it's not like a model is deployed only once and then you forget about it in the wild. That's not how AI works. So basically, we kind of close the loop between like the training data to the deployment and monitoring. And this will allow you basically to boost accuracy of your model over time. So your model is not going to degrade over time. So you're always going to keep up to date with new information as it comes in. It's also cost effective. So you don't have to basically use generic AI like ChatGPT and then pay a lot of money for each request. Even though it's a little bit cheap right now, but like when you scale this up to millions of requests, it becomes super expensive. So you can basically, by training your own AI, you can control the cost. And most importantly, you can basically deploy this model that's yours in your own server. So you don't have to kind of send your data to an outside third-party server, which can be, could be a risk endeavor. So basically, our goal is to make sure that the AI stays relevant, reliable, and accurate over time. And we provide this platform so you basically can do all this in a user-friendly platform.
I had a quick question.
Yeah, go ahead.
If you are doing the reinforcement learning, I heard you say, oh, maybe you need to do it once a month. Is it similar in nature to the concept of like 401ks where you're supposed to, or investing where you're supposed to do dollar cost averaging and always invest periodically in the same, no matter what the market is saying? Is that the same idea for reinforcement learning in order to catch those changes in data from data drift?
Oh, I see what you mean. Yeah. Yeah. I mean, it's kind of like the same principle, I would say, like responding to a changing environment. Mm-hmm. So basically, as your environment is changing, in this case, could be like the fraudster is getting smarter, or like your data is shifting over time. You want to be basically always monitoring that, and then retraining and reinforcing the model based on that new data.
Okay. And yeah. Everyone, please share any questions that you have so we can answer them live as well.
Sure, yeah, please do. So, yeah, basically, that's what we offer is a way to train your own AI and keep it, reliable and relevant over time. So for today's webinar, we're going to talk about like how AI agents specifically will help with credit card payment fraud detection. So it's the left one here. And so to talk about this topic, we need to introduce what agents are for the audience. Because there's a lot of right now like hype about AI agent and what they are, what they do, and so it's important to like lay the foundation of what AI agents are. So an AI agent is simply a large language model that has a memory. So basically, it can memorize previous action and states that it did, like a human being, right? Like I still memorize what I did yesterday, what I ate, what was the output of my actions yesterday. And I can reason. So the AI is able to reason based on the previous steps and then the goal that is trying to achieve. So basically, based on the previous steps and where it wants to go, it will update the plan basically. And then finally, it can use tools, and this is super important, and that's what you're going to discuss today. It's not just a chatbot where you can just talk to it passively. agents actually, you can equip them with tools. It could be, APIs, like Google API that checks, location of a certain store. Could be like running code execution, in a certain environment, access to a database. So it can do basically a lot of things. It knows how to use these tools to achieve the goal. And so the way it works, first it observes the world. So basically to monitor and query the environment that you care about. And next is it creates a plan. So it self-reflects. So it looks at the previous steps and try to update its plan accordingly. And finally, it acts, as I said. So using the tools in its possession, it can basically execute the plan. You can even do some purchases, run some queries and so on. So it can be fully autonomous, but I honestly don't think it's ready for that yet. Probably still semi-autonomous at this point. So that's pretty much what an AI agent is. So this is the definition of AI agents. And how are we going to use them today? So basically, we're going to use AI agent to detect fraud in credit card transactions. So let's say the user query is a fraud, JSON like this that has details. So given a user query, the AI agent will use its own tools that it has in possession. And we will equip this agent with a traditional machine learning tool. So this is a pre-trained machine learning model on basically millions of transactions. It has been trained on millions of credit card transactions. And this data is actually publicly available. If you want to replicate what we're going to show today, you can definitely do it. So we're going to give it a machine learning model in its possession to use. And second, we're going to give it the ability to retrieve historical transaction for that specific person. So let's say I purchased something today. It will basically look at all my historical, like last month transactions and get that data using from my database. And finally, we're going to give it this AI agent. We're going to give it another LLM. This is another large language model to basically reason about the data, reason about the historical transaction and the current transaction, and tell me like, okay, what's going on? Is this fraudulent or not fraudulent? And finally, the AI agent is going to aggregate all the data from the machine learning model, the traditional machine learning model, and the LLM reasoning output. And then it will give me a final recommendation. Is this like fraudulent or this is not fraudulent, and so on. So that's the idea. So do you have
two judges, in fact, or two steps in terms of looking at whether it's fraudulent or not?
Yeah. So in this instance, the AI agent is going to decide what to do. So we are only giving it like two tools to use, basically a machine learning model and another LLM to use. But we could have given it like 50 more tools, like check, the location of the store, go check the website of the person. So you can give it actually many tools, and the AI agent is going to pick and find, based on its plan, it will use the appropriate tool to get the job done.
Got it. Thanks.
Yeah, but for today, just like two tools we're going to use. So any questions so far? So the presentation is done, so we can move to the demo, but are there any questions we can maybe address?
Feel free to come off mute or to put them in the chat.
Sure. Well, if you have any questions, just put them in the chat and we can respond to them after the demo. Okay, so let's move to the demo. In this demo, we're going to show how to create this AI agent and how do we monitor it. So as I mentioned, so the first step is we're going to give it a machine learning model. And here I'm going to show just one example. Don't worry about the code part. This is not super relevant to this demo. But here, just want to show you, I'm using this model. Basically, it has been trained on credit card transactions, millions of them. And I'm going to test it just to show you what the output is. So I have this transaction here. The transaction, has the time of the transaction, the credit card number. And by the way, this is not private data. It's publicly available. I'm not stealing anybody's data. There's the amount, the zip code, the state, the coordinates of the store, the coordinates of the person, location, and so on. And all we have to do right now is we're going to go ahead and just run it and see what we get. So we have this transaction here, and we're going to query the machine learning model to see what we can get. So it's a simple response, which is basically it's 0, means it's not fraudulent. So the machine learning came up with a response that is not fraudulent. We'll see if that's true or not. But basically, this is one of the issues that I was talking about earlier. It's a black box, right? You don't know why. It's just not fraudulent, and you just have to accept it. So this is the first tool that we're going to provide to the agent. The agent is going to query this. It will send, given a transaction given by the user, it will send it to this machine learning model, and it will give us a response similar to this. Now, the second tool I want to show is the LLM. And for that, we're going to use UbiAi. Let me just... All right, let's go here. So this is the UbiAi platform. Basically, it's an AI training platform. Each card here that you see is an LLM or a deep learning model that has been trained or not trained. In this case, we're going to create a model, and we're going to use a DeepSeek model for our reasoning LLM. So if I click on this, I can basically open this API code, and then copy paste this API code into my application. In this case, I'm going to give this to the agent to use. And basically just query the data, send it, the text, the transaction in this case, and get back the output of this LLM. We have actually a lot of LLMs you can use, not just DeepSeek. You can use, Llama models. You can use Mistral, different distilled models. So we have over 10 models you can use out of the box. And so basically, that's how it works. I'm going to talk about monitoring later on, so don't worry about that part. And you can fine-tune these models, right? So you can basically, once you collect enough data set, you can fine-tune these models. So now let's go to the agent. Let's move here. Okay. All right. So to create the agent, we're going to use this tool called UbiAi. UbiAi is basically our second app that we have developed about 6 months ago. And with UbiAi, we're going to basically upload our previous transactions. And this is, again, publicly available data set. So we have these transactions here that we have uploaded. We have about 200 of them. If you go open one of them, you'll see the transaction here, transaction time, merchant, category, and stuff. And then basically what we're going to do is I'm not going to show it today, but we created the agent where we connected the machine learning model to it, and also the LLM API from UbiAi, this API here. And we configured it to basically respond to a user query that has like, credit card transactions. So to test it out, actually, all we have to do is click on this here on the right side. And then let's take, for example, this transaction here, copy paste it, put it back here, and then let's run it. So what it's doing right now, it's basically, it's taking this transaction and it's going to analyze it using the tools that I gave it. And the tools I'm using, as I mentioned earlier, it's a machine learning model, which is the one I showed here. So it's calling this right now. And after that, it's going to double check the if it's fraudulent or not using an LLM. So we'll see the result in a few seconds as this finishes. We have previous transactions here. We can also look at as this one is done. Oh, I used 200 here. Sorry, I think I have to redo this one. Okay, let's look at previous transaction here. So if you look at the output here, you have two. It was calling two tools. So the first tool is a fraud detector ML, which is basically our machine learning model. So if I open this, I can see that this response of this tool is giving us, there's no fraud, it's 0. And if you open the second tool, let's open this quickly. This is the output of the LLM. In this case, we're using DeepSeek. So as you can see, it's actually doing quite a bit of analysis. It's not just like saying 0 or not 0. And let's look at the analysis here quickly. All right, so if you look at the analysis, so it took the transaction details and basically start analyzing each component of the transaction. So for example, it was saying, okay, the transactions happened early in the morning, which may be unusual, but it's not really conclusive if it's fraudulent or not. The amount here of $316 is significantly higher than typical transactions. And what happened here is basically it was looking at the previous transactions I gave it in this project. So it looked at the previous transaction and it was reasoning about it, saying like this is the highest previous transaction was $311, which was entertainment category. And then basically it went like through the location of the merchant. It's saying like it's about 34 miles away from the location of the credit card holder. It says it's significant but not consistent. And basically, based on these all combinations, the time of the transaction, which was early in the morning, which the category, which is like grocery store transaction, it came up with a conclusion saying that this transaction is actually potentially fraudulent. So here what's happening is we have the machine learning model is saying that it's not fraudulent, it's 0. But we have the LLM analyzing the transaction is saying it's actually potentially fraudulent. And the agent here is going to take the output of these two and try to come up with a recommendation. So the recommendation here you can see at the bottom is, let's go back here. Yeah. So here, basically, it's going to, it kind of repeated exactly the output of the other one. And the conclusion is the combination of high transaction amount with a departure of established merchant category and considerable distance can be potentially fraudulent. And then basically it took also, the input also of the first one, the machine learning model, and then saying like, okay, basically it could be potentially fraudulent given the output of these two tools. The next step after this could be, for example, like a tiebreaker. So let's say there is kind of a confusion about like the two tools are giving like contradictory response. You might want to add another tool. For example, you might add another tool that checks the location of the merchant, if it's real or not. For example, let's say if the location is in the water or in the ocean, that's probably not real, right? So we could have added another tool here that checks the location, and that could be like also like a third layer of checks. So the AI agent basically is able to go over all of these and use all these tools to basically determine if it's fraudulent or not. And in this case, if we have relied only on machine learning, it's basically saying it's not fraudulent and we should not worry about it. And this is like a big problem because it's a black box, you don't know why. But using another LLM in conjunction with it, it's actually potentially fraudulent. And basically, because I know the data here, so this actually specific transaction was actually fraudulent. So the machine learning model made a mistake here, actually. And that was basically kind of flagged by the LLM as well. So if you want to change the data as well, you can. So right now, I can select, for example, I just want the 10 transaction to analyze. So I can do this. And then I can analyze. I can basically ask it the same question again. So basically what I'm doing right now, I'm giving it like historical data to look at. And then I'm asking it a question about the current transaction based on the historical data. So you can actually build your AI agent in any way you want. So you can, if you want to add more tools, you can. But this is basically a way to kind of augment the traditional machine learning model with a more like reasoning engines.
We do have a question.
Sure, yeah.
Couple questions. From Batra, it says, thanks for the presentation. Both tools do not have the same amount of information to feed to the final LLM, binary input for machine learning versus whole analysis for the LLM. Does this affect the final response?
So the final response is basically the agent is going to get the output of each tool. And for example, here it knows like the machine learning was saying it's not fraudulent. I don't think the type of the data will really matter, because the agent is going to reason and understand if it's binary, what binary means, and what like text from different output means.
Mm-hmm. Okay, and then we've got a question from Postbon. Does that mean the explanation from the LLM is a kind of explainability of the results? Means we don't need shape or line to examine the correlation of features, or if we still can or need to apply these methods here?
Yeah, if you're referring to the correlation of feature for the machine learning, I think that's still needed for sure. I think the idea here is to basically have another layer of check in addition to the machine learning, and also reduce kind of the I will not say like a human check, but flag potentially a transaction that were not basically detected in the machine learning, and then maybe kind of recollect the data and retrain the machine learning model better over time.
Mm-hmm.
It could be like a double check as well.
And then one more from Amal. Do we have a ground truth, or do we have ground truth labels to check the accuracy of the output? That's a question I had too.
Right. In this case, I do have a ground truth because it's a publicly available data. Mm-hmm. But when you are, this is actually a good segue to the next topic. But when you don't have the ground truth, you need to actually go and create it. So you need to log each interaction here, and then basically go and check it. And then create the ground truth and kind of retrain if needed. Mm-hmm. And that's basically what I'm going to show now. So basically, in UbiAi here, we used this model, the reasoning model, and we have been actually monitoring in the background. So if you go to the monitoring section here, this is basically a way to log every interaction with our model. So each interaction here with this second tool has been logged. Not this one, I think it's this one. So each interaction with the tool has been logged. And it's evaluated. So we are in UbiAi, we are using what you call LLM as a judge. So basically, if you go to the LLM evaluation setting here, what we are doing is we are rating the response of the LLM and basically checking its truthfulness with another LLM. So you have another model that's kind of monitoring another the base model that we use. So here, if you go to the evaluation, you can set up your evaluation metrics. So for example, here, I create this LLM to check basically whether this question was answered correctly or not, based on the data provided to it and the context, which is in this case the previous transactions, and check if it's truthful or not, basically. So I had two evaluation metrics here. So I have the correct, not correct, and then I have another one called factuality. So if it's factual or not factual, based on the data provided to it. And then here, as you can see, each row is a request that has been sent to my model. And then if I click on it, I can look at what the user has requested. This is the user prompt. Let's go here. So this is my transaction that I sent earlier. I also have the data that has been sent, a bunch of data here. And I can see also the output of my model here. I think this one is not good. Let's look at this one. Yeah, this is the output of my model. And then here what happens is the LLM as a judge is going to look at the input and the output and is going to give its evaluation. So this is the evaluation of the LLM as a judge, and it's saying based on this input, it looks like input and output, it looks like it's correct, and also it looks like it's factual. And actually, in some cases, it flags incorrect ones as well. So if I go here, so this is another one I did earlier, you can see that the LLM is saying, not this one did not work. Let's try this one. Okay, so here basically it's saying the AI assistant analysis is thorough and consider multiple factors. However, the conclusion contradicts the reasoning. While the AI highlights several anomalies, it ultimately labels the transaction as not fraudulent, which is inconsistent with the present evidence. So this was flagged as incorrect. Basically, the reasoning here was flagged as incorrect, but by another LLM. So this is where the human will come in, and then we'll double check this. So, okay, we have incorrect, so we're gonna go here, and then we're gonna rate it as accurate or inaccurate. And then we can leave a comment here. So this is the reinforcement learning part that I was discussing earlier, where you can collect this data set of accurate or inaccurate. You can also work with an LLM as a judge to help you here, and then collect this data set, and then select it, and then append it to a new data set, and then basically retrain the model with reinforcement learning, so next time it gets better and better over time.
Mm-hmm. We do have another question.
Sure.
Baha. I have a question regarding the model's ability to process past transactions. How do you handle the context length limitation when dealing with a long history of transactions? Are you providing recent transactions, or do you have a strategy
Good question,
selecting the most relevant ones? And then he goes on, given that longer prompts can increase the risk of hallucinations, did you implement any custom logic to mitigate these challenges?
Right. In this case, I'm giving it only 10 transactions. So I took the 10 recent transactions and I just fed it to the model. But what I recommend to do is basically use some RAG system, retrieval augmented generation. So basically, given the current transaction, please find the top 10 or top 20 or top 30 similar transaction in the past, and then find if there's any correlation or anything like that. That could help. It could be like similar transaction or like not similar transactions. So you can actually select what you want. But I recommend to definitely not feed like 100,000 or 200,000 transactions to an LLM. That's not a good idea. It's probably gonna hallucinate and start doing random stuff. So definitely give it like more relevant, context when you query it.
Mm-hmm.
Yeah.
I have a quick question. So if you were a financial institution, you would be using all of your customer data. Is that correct? In this case, to do the training and all of these potential steps, or
Right.
would you need to do and would you need to adhere to any privacy stipulations or masking? I'm just curious, how a financial institution would go about working through this.
Yeah, I think for financial institution, definitely hosting this entire process in their own server is a must. I don't think they can basically take the risk of sending this data, obviously, to a third party like cloud API. Mm-hmm. So we definitely recommend to basically set up this entire process in their own server. Yeah, and that's what we actually do as well. So this entire platform monitoring system using these AI models, this all can be deployed on premise right now. So if there's anybody who wants to try it out and use it, we can discuss for sure.
And of course, on top of that, the compliance is going to be important too, right?
Right, exactly. The compliance, yeah. So as a conclusion here, I would say basically the takeaway message is even though AI agents, are like overhyped right now, they're actually useful. but they're useful to a certain extent where you need to basically keep reinforcing them and monitoring them over time to make sure that they're not like doing anything like incorrect. And the second takeaway message is we don't have to discard traditional machine learning model. You can actually combine reasoning engines with traditional machine learning models to create something more robust.
I think it'd be interesting to do that study to see like what is the difference in accuracy, or
Right.
between just the traditional machine learning versus now this solution.
Yeah.
Yeah.
Exactly. Yeah, I think it'd be nice. So one thing I noticed, right? Like I think it's very common right now in the field. If you ask the same, if I give it the same transaction 10 times, it's not going to give me the same response 10 times. This is one of the issue in the field of LLMs. There is a variability, basically, and you can track that variability in the system here and refine tune and reinforce it so it becomes more reliable. So here I actually tested this like yesterday. I asked the same question 10 times, and I think 2 out of 10 it was giving different answer. So that's not acceptable, right? So that's where fine-tuning and reinforcing this model is super important using this technique.
And I was going to say, I like how in your demo you also had the ability for human intervention, right? Because nothing's foolproof with AI. As you were saying, there's these variabilities, you get different answers. AI can continue to have some reasoning on top of that to mitigate some of that, but you're always going to have this option of, in a robust system, having AI pull in human to provide their last bit of insight.
Yeah, and this is where the user rating, the human rating is. So you can rate quickly here, inaccurate, accurate, or inaccurate, and simply collect the data set. You might need 500 examples of this or 1,000 examples of this, and then you can reinforce the model in the next version. One last thing here I want to show is just with Kudra, you don't have to just upload text files like this. You can actually do the same thing with PDFs. So you can basically upload PDFs and then feed these PDFs as a reference data to the agent as well. So it's pretty versatile. It can work with PDF, text files, and so on. Okay, so let's go back to the presentation. If there is, are there any other questions, Sarah?
No, that's it for now.
10 minutes. Okay. So thank you so much for joining in. Basically, in summary, we believe Gen AI reasoning models plus traditional machine learning model can really help increase efficiency in like fraud detection through multiple layer of analysis. And most importantly, as you saw, there is more explainability. So the machine learning model is a binary, it's like 1 or 0, that's it. With the reasoning engine, it can actually explain why. And in this case, it actually found out it's actually the opposite of what the machine learning model is doing. So it's kind of reducing this black box problem that we have in machine learning. And the third takeaway message is the continuous improvement is super important, where you can basically rate the response of the model with like an LLM as a judge and a human. So that's super important to have in your AI stack.
We have one more question that just came in.
Sure.
As we were asking if there are any more. So Amal asked, doesn't the use of an LLM to solve problems like fraud detection increase the cost of solving this problem compared to the majority voting, for example, on different machine learning models? Does the gained insights outweigh the cost?
Yeah, I mean, the cost is a concern, I agree. But the good thing is you can basically train smaller models, like small language models, like 8 billion parameters, and distill them based on like larger models. So you can actually reduce the cost quite a bit. I mean, I think the explainability is super important. That's like almost having a human doing basically looking at the data and reasoning about it. So definitely explainability is a big problem and should be, and LLMs are addressing it right now.
Great.
Right, so not sure if you have any last remarks, Dirk or Sarah?
No, this is really great. I love the demo.
Perfect, thank you. Two last things. So we have a survey that we're going to send right now by email. Please, if you have time, please fill out the survey, and we'll provide you with UbiAi credits, so you can basically log into our platform and you can create your own model and start, playing with it. We're also going to provide free access to our Kudra to test out different agents if you'd like. And finally, if you are exploring different ways to implement AI in your business, we will provide also free AI assessment. So if you'd like to schedule a call with us, we can basically discuss and explore how AI can help your business. And finally, if you would like to speak in this webinar, if you have a specific topic that you want to discuss, please send us an email. We're always looking for experts and interesting topics to discuss in this webinar. And that will conclude the webinar.
Thank you so much, everyone, for joining us.
Thank you so much.
Thank you.
That was this one. All right.
Thank you.
Thanks, everybody.
Thank you, everyone. Glad you could.
Thank you. All right.